Welcome, everyone. On behalf of OPWA, I'd like to thank all the attendees for taking an interest in today's webinar. Today's webinar is entitled Trees and Construction, Designing and Constructing Projects While Respecting Tree Resources. This webinar has been organized by the OPWA Education Committee. My name is Philip Rowe from R.J. Burnside and Associates, and a member of the OPWA Education Committee. I'll be your host for today. OPWA is a not-for-profit organization for professional public works practitioners. The Ontario chapter is one of 63 chapters that make up the American Public Works Association. We have over 500 members who are employed by provincial governments, municipalities, consulting engineers, utility companies, contractors, and suppliers. The Ontario chapter is also supported by two regional branches, the West Central branch in the Niagara region and the Ottawa Valley branch in the Ottawa region. OPWA's mission statement reads, Connecting the Public Works Community. OPWA provides its members opportunities to connect through workshops, conferences, and social events. Another great way to connect with those in public works is to join an OPWA committee. There are 9 committees within OPWA, so there are also many opportunities to match your interest. Your creative ideas on volunteer assistance is wanted and welcomed. If you're not a member of OPWA, we encourage you to consider joining. If interested, more information can be found on the website given on the screen. OPW Connects is an opportunity to connect membership with education and technical resources. Today, we connect with fellow OPWA members who are experts in their sector. Typically, we plan for one webinar each month. Here's a list of upcoming events. May 28th, Meaningful Engagement with Indigenous Communities. On June 25th, EV charging stations for beginners. August 27th, benefits of BIM 3D modeling. And on September 24th, changes to the CC-DC contract. All participants are free to attend these webinars. We also have many other events going on at OPWA. National Public Works Week is a week of recognition for public works professionals across North America. During National Public Works Week, we will be having our OPWA Awards Luncheon on May 22nd, celebrating outstanding project achievements. It will be held at the Mississauga Grand Banquet and Event Center, and it's an opportunity to recognize your peers for their excellence in public works. Some of the awards include Project of the Year awards and individual awards. Also, our popular annual OPWA Golf Day will be held on June the 19th at Flamborough Hills Golf Course. Please visit our OPWA website for the most up-to-date information. Attendees' microphones will be muted and cameras will remain off. Questions will be addressed at the conclusion of the webinar. Place your questions in the Q&A box during the webinar. The Q&A icon is located in the taskbar at the bottom of your screen. Click to enter your question. The webinar duration is approximately 1 hour. I would like to formally introduce our presenters from R.J. Burnside and Associates. While I do so, I will ask Kevin Butt to get their presentation set up on the screen. Kevin Butt has 25 years of experience working in the environmental industry, preparing natural heritage and tree studies throughout Southern Ontario. These studies have been completed for both public and private clients and range in scale from single residential lots to major road corridor to multi-developer blocks. Study deliverables include environmental impact studies, arborist reports, tree risk assessments, tree appraisals, preservation plans, ravine stewardships, and mitigation designs. Kevin has worked with governments and review agencies, property owners, and the public through all stages of approval. Mackenzie Dawson is an International Society of Horticulture certified arborist. He's responsible for preparing arborist reports, tree preservation plans, environmental monitoring reports, species at risk assessments, and environmental impact studies to accommodate site alterations, planning, and environmental assessments. His role includes work in both public sector, capital works, private sector land development, and environmental monitoring. Mackenzie is knowledgeable in federal, provincial, and municipal environmental legislation and is experienced in liaison with planners, conservation authorities, and government agencies. Mackenzie and Kevin are arborists who will share the fundamentals of care and consideration of trees before, during, and after the construction period. Access for machinery, excavation, and fill areas, and material stockpile locations can all result in significant impacts to trees within the adjacent to construction work zones. These activities can lead to tree damage and/or removal or unnecessary liability if trees become compromised. Mackenzie and Kevin will also discuss standardized requirements in many municipalities for tree investigation, their implication and challenges on construction projects. With that, I turn it over to Kevin Butt.
Thanks, Philip. Can you just confirm that you can see the slide okay?
Yes, I can, Kevin. Thank you.
All right. Well, thanks to everyone for attending today. We understand we have a number of urban forestry staff on the webinar, so we hope that we do the subject justice, including royalty such as Max Dida and Yaroslav Medwidsky from the City of Toronto. Welcome. One thing we're finding on some of the capital projects that we've been working on lately is that engineering and public works staff are not consulting or circulating materials to municipal forestry staff early on enough in the process. So there can be some challenges with expectations or misunderstandings between objectives of the groups. We're hoping this presentation provides some understanding for the managers of public work projects about the value of arborists in their projects. Here's our agenda. We'll be talking about the benefits of urban trees, context with public work activities, tree inventory and data collection, Crown Reserve versus tree protection zones, go deeper into tree protection zones and the applications of them, planning ahead, tree impacts for construction, species tolerances and construction, post-construction inspection, mitigating tree impacts, tree hazard versus tree risk, applications for tree appraisal, ecological timing windows, tree protection standards and municipal tree bylaws, and then we'll finish with some summary points. Mackenzie.
Urban trees are an integral component in modern-day urban infrastructure. As the primary interface between urbanized and natural landscapes, urban trees are systematically predisposed to adverse growing conditions, yet they provide us tremendous benefits that influence us in our day-to-day lives. Trees are unique in construction, as typically they are one of the only things we are trying to manage that are a living organism, to maintain them on the landscape, which are both dynamic and complex in nature. To name a few, but not all, benefits of urban trees As I know many people on the call can add to this list, trees have engineering uses. They can reduce glare and reflection in city streets. They can assist with erosion and flood control. They can reduce our urban wastewater, capturing rain runoff and infiltration of soil. They provide even small inconspicuous advantages to directing pedestrian traffic, providing aesthetically pleasing buffers or barriers. They can improve our microclimate, things with windbreaks, a source of significant shade, reduce heat reflection, providing a cooling effect within urban city centers, and can effectively reduce the interior temperatures of buildings at times, which can increase cost savings. They can have environmental uses. Of course, they produce oxygen and sequester CO2. If you take a healthy, mature beech, it can produce up to 1.7 kilograms of oxygen and sequester 2.5 kilograms of CO2 in a given hour. Trees, of course, reduce air pollution, mostly through the interception of wind, reducing wind speed and capturing airborne particulates, very particular for that of dust buildups in urban centers, and can help absorb heavy metals suspended in air. They provide urban wildlife habitat. Songbirds, squirrels, and pollinating insects, to name a few, play an important role in nutrient recycling and integrated pest management processes with biocontrol. They have educational purposes, fostering environmental awareness and encouraging outdoor learning. They have economic purposes. Of course, they can increase property values. They have byproducts for things like edible fruit gardens, firewood, providing building materials. Of course, they have social impacts. They have aesthetic value. Now, that's quite difficult to quantify sometimes, but trees can provide an outward sign of physiological thought, such as a memorial tree or trees that can be planted in symbolism. Lastly, they have mental and physical well-being benefits. Trees play an important role in a healthy social society, promoting physical activity and increasing connectivity. They can provide a real connection with nature, and they can provide a sense of place, encouraging citizen involvement, and can be a foundation of historical areas.
So many municipalities have targets for tree canopy to be about 30% of the coverage within the municipal limits, which most municipalities are currently not accomplishing. Therefore, damage of trees or reduction of the existing canopy is generally not supported. Municipal tree bylaws have been created to restrict tree loss and may be applied to capital B projects. For instance, one of our clients is Halton region that is subject to the bylaws of the town of Oakville or the city of Burlington while working on regional infrastructure projects within the municipality. Public projects such as road improvements, linear infrastructure like water and wastewater mains, and bridges often interface with areas where trees are found. Ownership may be public within road right-of-ways, parks, or conservation lands, or private trees within residential yards or commercial properties. There's an expectation that these projects, which are often very visual, are subject to the same obligations of tree protection that a homeowner, commercial interest, or land developer has for tree protection.
For most tree inventories related to construction projects, it is important to determine the extent of proposed development and establish a defined study area. This can sometimes be very clear, such as a project that's linear on a single street, maybe between a couple intersections, or it can be more complex for developments on multiple parcels of land that are not defined traditionally by existing boundaries. The criteria of inventory must also be established to establish what kind of data are we collecting. Is it trees of a certain size, no less than a certain diameter, maybe trees within only private lands, or trees of all sizes within the public right-of-way? Are we collecting only native or maybe introduced species, maybe excluding that of invasive trees or invasive shrubs? Data is typically collected using geographical information systems like ArcGIS, supplemented with a GPS receiver to improve positional accuracy, like a Trimble unit, which we create points and polygons that are georeferenced with inputted fields of data that are both qualitative and quantitative, such as the diameter at breast height, a standardized measurement of the tree trunk, roughly 1.37 meters. We collect the species of the tree. We identify the ownership. Is it a tree strictly on private land? Is it on public land, maybe within a public park or right of way, or maybe it has shared ownership? we look at the health and structural condition of the tree, and sometimes we approximate the height and determine the extent of the tree's canopy. It should be noted that this data does have an expiry date, generally defined by the regulatory agency or municipality. Generally, the tree data expires after 2 years has elapsed from this initial inventory, with significant project delays that may result in the arborist or assessor needing to go back to the site to collect updated information, to maybe account for the tree removal or new tree plantings that have occurred on the site, or maybe changes in tree size and condition. A challenge we see with tree inventories for public projects is there can be limitations to enter properties. As we know, tree inventories for projects on public land sometimes require tree information on immediately adjacent private land that may be impacted by the development. Generally, collecting trees information for trees within 6 meters of construction disturbance. However, this area for collection may be larger for some municipalities. And as we know, roots do not respect these property lines. Any grading or disturbance that extends to that property line can impact privately owned trees. This requires the assessor or arborist to collect data of private tree assets from the public right-of-way and approximate measurements and conduct a limited condition assessment. Tree data in GIS, once it's completed, is converted and overlaid into an engineering drawing with a proposed design, such as the placement of utilities, maybe showing areas of demolition, new infrastructure or grading, where impacts to existing trees that we've collected can be quantified.
Sorry, I got excited about giving my slide. So crown reserve is generally considered the extent of branches or drip line that was historically used for determining setbacks from trees. Unfortunately, these extents can be variable by species, setting, and management. If you want to look at the diagram that shows the tree form, you can see that a narrow canopy of a conifer versus maybe a sprawling apple tree can have the same DBH, but the influence of the crown reserve might lead one into thinking one gets a larger setback than the other. Otherwise, setting, a canopy shape in an open grown condition will be very wide versus a light suppressed or restricted growth area within a narrow canopy. Also, a woodland edge tree may have a one-sided or imbalanced canopy. And then there's management. Pruning artificially changes the shape of the canopy for aesthetics, clearance, and maintenance. It is for these reasons that the crown reserve or drip line has been used less and less as a metric for tree protection limits. Instead, more municipalities are adopting the establishment of a tree's protection distance using minimum tree protection zones, determined based on the diameter at breast height. A tree's protection zone can be established by this predetermined limit. We've provided an example of what a standardized root system looks like on the left-hand side. So you can see it's similar to a wine glass that's wide and shallow. The root zone is that shape because roots need nutrients, water, and air, and they don't get that by going down deep into the soil. Tree root zones are generally quite shallow within the soil profile, with most of the roots in the top 30 centimeters of soil. The table on the bottom right-hand corner illustrates tree protection zones required based on the DBH ranges found within the tree protection guidelines or tree bylaws of many municipalities. Minimum tree protection zones in the right-hand corner show the radius from the trunk that is used, therefore double it to make a circle around the trunk. The predetermined setback and corresponding DBH grouping, like that table shows, is defined by the municipality or regulatory agency and may vary from what this table shows. For instance, some municipalities may provide larger setbacks for increased protection in areas of greater ecological value, like ravine areas or open space lands. Disturbance beyond the tree protection zone will still impact some roots, which often extend 2 to 3 times the width of the crown reserve, but they are generally not considered to be critical for the long-term survival of the tree. We should try to avoid impacts to the tree protection zone and the tree protection zone should only be considered a minimum setback area. Here's some examples from some of the construction designs that we've identified conflicts or overlaps with new elements such as trails, access routes, and multi-use paths. These drawings are part of a more comprehensive arborist report submission that discusses the methodology of the study, analysis of impacts, proposed development, and recommendations of mitigation. This document will also include mapping and data for all the trees reviewed in the study area that has been coordinated with the engineering plans. It's important to consider that there are some temporary impacts such as excavation limits, work compound areas, and access routes that may not always be considered since they are temporary features that will be removed over the course of the construction period, but can be just as impactful to trees and must be considered. Planning ahead with a detailed design after you have the tree information is critical for tree retention. Things to consider are extent of disturbance resulting from cut or fill grading, routing of new services and excavation limits that are needed, access routes, storage and stockpile locations, including compounds, parking areas, locations of tree protection fence and erosion control fence, short-term ponding areas. Implementing the tree protection measures can take a few forms. The top right shows the implementation of tree protection fencing that must be installed before a contractor begins work. In this case, orange mesh was used for visibility within the right-of-way, but other areas may use wood hoarding, page wire, or modular fencing. Modular fencing can be reasonable to use if it is affixed to the ground and does not move for the duration of the project. You'll also notice in the photo that it illustrates a tree protection sign, which is often standardized by the municipality. It documents what the tree protection zone is and contact information. Some municipalities require the installation of the fence and notification of Urban Forestry Department so they can inspect prior to the issuance of the permit that would commence work.
Now let's discuss what actual construction-related impacts occur to urban trees. It is important to note that impacts can be observed immediately or within a very short time frame, but sometimes impacts can take a long time to establish or become visible, even years post-construction activity, which can present challenges regarding the cause and effect. The most obvious and distinguishable impact to trees is root severance. As discussed previously, the majority of tree roots are found within that first 30 centimeters of soil. Damage or removal of both large structural holding roots and fine absorbing roots, also known as feeder roots, will disrupt the structural holding or load capacity and reduce the tree's nutrient uptake capability, respectively. The severance of roots is commonplace for linear infrastructure replacement and things like grading slopes. Unfortunately, feeder roots are a common issue around our sewer systems as they grow towards water availability from things such as the buildup of condensation on our infrastructure or even leakage. A runner-up for construction-related impact is root compaction. Compaction was and sometimes still is a very common oversight in regards to the preservation of trees. Access paths for heavy machinery, established working compounds, and equipment storage areas within close proximity to the tree can significantly disrupt the soil porosity, reducing its water and nutrient uptake capability, and even crushing the fine absorbing root systems. Once compacted, new root shoots may not even be able to penetrate the soil, especially for those with project areas with heavy clay sites, and create an asymmetrical root system. This can lead to a hidden structural defect. Typically, trees do not display signs of stress in the short term from compacted roots and can decline slowly over time. Branch pruning is a common practice in the maintenance of urban trees and regularly part of forestry mitigation strategies, particularly when performed according to best management practices. However, trees in urban environments frequently conflict with old or new infrastructure above the ground, and a common example being utility lines or hydro lines. It is important to understand that there is a threshold for this tree pruning, and trees generally cannot withstand more than about 30% of their crown being pruned without subject to significant stress within that growing year. This is challenging to abide by sometimes during clearance pruning activities. Removal of large branches for equipment access and development frequently lead to structural problems and a greater disposition to tree disease, defect, and a shorter life expectancy on like a municipal asset. Other impacts generally relate to the change in the tree's local environment. Just like us, trees are masters of adaptation, some better than others. A dramatic change in sunlight can clearly impact a tree, such as removing a building or structure adjacent to trees that have been subject to a certain amount of shade for decades. Significant tree removal can cause changes to the edge of trees that are preserved or remain on site. Most commonly, a dramatic change in wind exposure. Interior trees on a woodlot grow physiologically different than that of trees established on the edge, or changing the local growing competition for light and nutrient availability, which this can all be referred to as edge effects. Another consideration is the local moisture regime. Significant changes like grading, installation of new ditches, swales, and exposure to, say, road salts can play a factor. Tree drought is commonly observed from increased soil salinity, and fine absorbing roots can easily drown in saturated soils. In even severe cases, significant saturation around the tree's root plate can disrupt the load bearing capacity of structural roots and can even lead to uprooting. When considering impacts to trees, tolerance to a specific construction-related stress or injury is important to consider. Impacts from construction differ among tree species. Some species are more naturally tolerant to maybe a specific stress than others. Some species are more tolerant, say, to soil compaction. We can look at Freeman maples, white spruce, maybe bur oak, selected for high foot traffic areas. Some species maintain a higher modulus of rupture and can tolerate periods of heavier load carrying capacities, like ice storms, including trees like Douglas fir, white oak, shagbark hickory, and maybe ironwood. And contrarily, some tree species are sensitive to stress and needs to be accounted for when evaluating a specific impact for a tree on a construction site. For instance, oaks are notably sensitive to certain minor root severances. Beech and pine trees, their roots are more sensitive to fill material. Hickories are known to have limited climatic tolerances, responding poorly to small changes in their microclimate, particularly disruption of light availability. Black cherry or black walnut have poor compartmentalization properties and can be more susceptible to minor physical injury to the trunk and branches. Some tree species require greater protection than others, and is important to be accounted for during these tree studies. But as a rule of thumb, regardless of the species, we know younger trees that are more vigorous can adapt to certain and are more tolerant to certain construction stresses better than larger, mature, or overly mature trees. And this should be considered when establishing candidates for preservation. In today's age, we have tree nurseries that provide a wide assortment of cultivated trees that are genetically engineered to propagate certain traits. Commonly, tree cultivars can be displayed and selected for certain colors or producing more or less fruits for horticultural purposes. But for the purpose of construction-related activity, a tree's ability to withstand stress is paramount. Some species can be selected based on, say, salt tolerance. We can take a look at our thornless honey locust, which are planted as a very common street tree in many suburban communities in southern Ontario. It is important to note during the project landscape and restoration phase, selecting the appropriate tree species for the appropriate planting place and environment is crucial for long-term restorative success. And a summarization of these factors can include the tree species hardiness, shape, and ultimate growing capability, its susceptibility to local pests and pathogens, and combined with the site's physical growing space above and below ground, any future obstructing objects, maybe for infrastructure installation and maybe replacement, and of course the moisture regime and light availability that may change over time.
Post-construction inspection of trees is unfortunately not very common. Reasons for inspection could be if tree conditions change over the course of the construction period due to unanticipated mechanical damage, fill or cut, flooding, compaction due to stockpile, parking or access use, field fitting changes or changes to the detailed design not considered in the tree preservation plan. Trees or branches may require removal, pruning, or other corrective actions prior to the contractor demobilizing from the site and allowing public occupancy and use. Once substantial completion of construction has been achieved, inspection of the trees adjacent to the work zone is highly recommended to identify problems in order to reduce liability resulting from injury, property damage, service disruption, and aesthetics. A decision may require removal, loss of letter of credit or deposits, or fines or punitive action against the contractor. Inspection of the installation of compensation or mitigation plantings by the arborist may also be considered. However, this inspection may be done by the project landscape architect that is overseeing the plant warranty.
There are several mitigative measures that can be specified on construction sites to reduce impacts to tree resources. Anti-compaction strategies. In cases where tree protection zone encroachment is required for site access, swamp mats or an alternative anti-compaction mat can be installed along the access path alignment to prevent soil compaction, particularly important for sites with saturated soils. Anti-compaction mats are commonly used to align site access paths through city parks or golf courses where there's a higher density of significant tree preservation. Pneumatic excavation methods can be an effective low-impact alternative to traditional excavation using air spade technology or a hydrovac truck to displace the soil volume and root system without disruptive root severance. Pneumatic excavation methods must be set to a setting of low pounds per square inch, generally not recommended to be greater than that of 90 psi, and to a depth of at least 75 centimeters. Once roots within the tree protection zone are exposed, root pruning according to best management practices can be performed by or under the direction of a certified arborist, where roots are cut to generally 15 centimeters from the edge of that pneumatic excavation. Once root pruning is completed, something like service installations can begin, and immediately following completion, hand tools are generally recommended to reinstate the soils within the tree protection zone, using topsoil or native soils to the finished grade. Pneumatic excavation has become commonplace for public service replacement projects, such as installing sanitary laterals to properties from water main replacement. Post-construction, it is sometimes beneficial to prescribe horticultural practices to trees on site that have been subject to certain construction-related injuries. You could include restorative pruning practices to prune or elevate the crown for a change in land use, provide deep root fertilization to enhance nutrient availability within the soil for trees with increased susceptibility from construction-related stressors, or soil decompaction through aeration practices or vertical mulching to facilitate new root growth and increasing oxygen exchange and water and nutrient uptake. In the past, the process of inspecting and evaluating the health and structural condition of a tree in relation to the harm that it could occur by failure was deemed as a hazard assessment. This has, for the most part, has now changed and standardized as risk assessment, which more accurately reflects the assessment process. As we look at trees, the hazard or the source of damage or harm is either a part of a tree that might fail, and also assigning a tree either a hazard or not a hazard label can become problematic since no tree or part is without some sort of risk. When we look at risk, it's the combination of the likelihood of an event and the severity of the potential consequences. And again, no standing tree is without risk on the landscape. Arborists and foresters use a complex tree risk assessment process, generally defined by the International Society of Arboriculture, to evaluate risk. In a nutshell, the process can be summarized in 3 areas of evaluation. The first is the likelihood of failure. We look at the tree health, the species. Is there any response growth, any existing defects and conditions within the site? Look at the site factors and any specific loads on the tree. The second is the likelihood of impact. What is the occupancy rate? A tree adjacent to a concessional road where cars are driving 80 kilometers an hour has a very different occupancy rate than that of a tree backing onto a popular playground. We look at the location within the target zone, the protection factors. Is a pedestrian under a bus shelter, or are they waiting to walk across the street? And of course, we look at the direction of the fall. The third evaluation is the consequence of failure. We look at the size or the extent of the hazard or tree part, the fall distance, protection factors, and the value of the target. Is the hazard or tree part falling on an abandoned shed or maybe an occupied bungalow? This is an important process for construction projects when evaluating tree impacts. Trees as public assets could exceed an acceptable level of risk and become a liability. Construction can directly or indirectly alter or disrupt the local environment, predisposing trees to stress or directly changing their structural form. If we look at a simple example, we can look at the conversion of a discontinued railway corridor that's going to be converted into a multi-use path. This conversion of land use must consider a change in tree risk. With a once abandoned area converted into a maintained recreational space, we have a significant change in the occupancy rate, protection factors, and the value of targets. And it is important to develop a threshold for this risk and determine what is acceptable with a standard of care based on the best management practices. Occasionally, arborists are required to determine the monetary value of trees within the work zone. This appraisal process is developed by the Council of Tree and Landscape Appraisers and Ontario's Supplemental Guide to Plant Appraisal to establish a process for appraising the monetary value of trees, commonly known as the trunk formula method. This process takes into account a wide assortment of factors, including the tree species. Some species are higher valued than others for maybe their stronger wood carrying properties. They may require less maintenance. They may be longer living. They may be of a certain cultivar for tolerance. And some tree species have historical importances. We can look at our provincial tree, the eastern white pine. The size matters that can influence that value. The condition, is it a healthy, more vigorous tree that is free of defects, disease, and any local pests and pathogens? We also look at the amenity value, the tree's placement on the landscape. Is the tree planted too close to a sidewalk or path? Does it have enough overhead room for future growth if there's any overhanging infrastructure? What is its contribution on the landscape? Does it provide shading benefits for multiple adjacent home owners? Was the tree planted in memorial? Does the tree contribute to a surrounding garden, or is it part of a edge to improve sight lines? Or has it been conflicting with, say, sidewalks for quite some time? And we also look at the approximated contractor removal cost. These factors are recorded and quantified to calculate a total appraised value assigned to trees within the project area. Many municipalities have adopted a refundable tree guarantee deposit or an alternative insurance method. In the application of tree appraisal, this method of security holds the contractor responsible to ensure compliance with the tree protection and mitigation measures prescribed during the construction phase. A municipality may require a security deposit in the amount of the appraised value of trees to be preserved. And if non-compliance is determined or any unintended construction-related injury or removal occurs, the resulting damages are subtracted from the refunded deposit in the appraised value of damaged or removed trees. There can be great variation in the appraised value of trees, with some individuals can exceed that of $25,000 in Ontario. In general, the larger, more established and healthier trees in the landscape, the greater the benefits received from that tree, the greater the asset is, and the higher the appraised value. This method of appraisal provides an industry standardized way of establishing consistent values. However, placing monetary values on trees is a challenging prospect at times. As we know, trees can possess intrinsic value, and it's not just simply replaced in the landscape. And the benefits of large, mature trees in the urban forest can take decades to establish. As we know, trees can provide significant shelter and habitat for wildlife, even in busy construction zones, which needs to be accounted for. There are two general ecological windows that apply to timing constraints on projects that require tree injury and removal. The first being the bird breeding window, which is April 1st to August 31st for most bird species, regardless of the calendar year. And for some bird species, the destruction of their inactive nests may still be prohibited, like barn swallow, osprey, and the great blue heron. In select cases, when tree removal is required within the bird breeding window, a pre-construction nest survey can be completed by a qualified ecologist no greater than 3 days prior to clearing activities. If nesting is identified, a species-specific buffer will be applied to the applicable area until the nest is no longer active. However, even if only nesting behavior is displayed by birds on site, or if the qualified ecologist cannot obtain clear observations with certainty, the go-ahead wouldn't be given. Pre-construction nest surveys are typically restricted to that of sites with very few trees or open grown, where clear observations can be made without any obstructions, generally 360 degrees around the tree. But needless to say, these surveys can come with great risk, and it's strongly recommended that all tree removals, including those of grubbing, occur outside the bird breeding window. Second timing constraint is for maternity roosting bats. But it is important to note specific requirements determined by a qualified ecologist must be met in order for a tree to be deemed bat habitat. The active bat window is from April 1st to September 30th, and a total of 7 species of bats are listed under Ontario's species at risk, 6 of which roost in treed habitats, like trees' internal cavities, loose bark, and even woody snags. When we look at tree protection standards from different municipalities across Southern Ontario, we see some similarities and differences alike. In general, larger, integrated, and densely populated municipalities, like those within the GTA, have more regulations in place for tree protection compared to that of smaller municipalities that have significant canopy cover. Tree protection standards are set forth in municipal bylaws, which can vary in detail greatly. For instance, I know many people on the call that may be involved with the City of Toronto in any capacity are probably familiar with Toronto's 5 categories that are evaluated trees based on their size and location. The first 2 tree categories cover trees that are 30 centimeters in diameter or greater, with Category 1 trees designated for those on private property within on the project site, whereas Category 2 are for trees on private property within 6 meters of the project site. Category 3 is designated for trees of all sizes within the city-owned parklands. Category 4 is designated for trees of all sizes within the designated Ravine and Natural Feature Area, which is a regulated area defined by the city. And Category 5 is designated for trees of all sizes within the public road allowance. And you can see permits to injure or remove trees are subject to these types of tree categories, which also has implications on the quantity and maybe type of tree replacement required. Similar detailed regulations can be found in other places in Ontario, mainly large municipalities like the town of Oakville, city of Mississauga, or maybe city of Burlington. And contrarily, smaller municipalities sometimes don't have such detailed protections or maybe individual tree protection bylaws. For instance, the town of Collingwood relies on a modified tree protection bylaw that only protects those trees of removal or injury on lots greater than half a hectare, but also under specific criteria, like trees within a defined woodland or woodlot, or when there are more than 5 trees proposed for removal on a given property, or trees greater than 30 centimeters in size, or within those on municipal lands. Say the township of Uxbridge defers tree protection to the region, that is the Durham Region's Woodland Conservation Bylaw. Or a different scenario, the town of Halton Hills regulates tree protection through a combination of the Halton Region's Woodland Protection Bylaw and a privately owned tree management strategy, which engages the community to develop local strategies for private tree protection, tree canopy management tools, developing education and incentives for tree protection management.
So we've given you a chance to use the arborist lens for tree preservation within the context of public works projects. A few of the takeaway items that we wanted to keep with you are public work projects are often proposed where trees are found that may be publicly or privately owned, and all efforts should be made to protect the municipality's tree canopy. Tree data collection is important for determining project constraints and actions that may be required throughout the construction process. It's highly recommended that an arborist is involved in the planning stages throughout construction and post-construction. Mitigation options exist for managing some constraints and working around trees, but the first step should be attempting to provide the greatest amount of setback reasonable. Thank you. I'll let Philip take over if there's some questions.
Thank you very much, Kevin. Thank you to yourself, Kevin, and to Mackenzie for your very informative presentation. I know from personal experience that tree health, preservation, protection, management, even development of mitigation measures all start from an EA stage right through to construction and everything in between, detailed design. Oftentimes we get the best results when those considerations are done right at the beginning. So I certainly really appreciated the comments that you made here today and the details that you provided our membership. It's an important aspect of our world of construction. It's an important consideration for the health of our community. So this is an extremely important topic. I don't see any questions so far. I'll wait a couple of minutes if any folks have any questions. We do intend on posting this presentation on the OPWA website later on. So it will be available to folks that were on this call and others for your review later on. So I'll wait a couple minutes here to see if there's any questions at this time.
Philip, I can jump in actually here. Maybe we left them speechless, and that's okay. A question that often comes up with tree preservation is horizontal directional drilling, microtunneling, HDD, trenchless technologies. And is that okay to go through tree protection zones? Because in the 2D plane, they seem to cross over and overlap. Generally, those are considered not issues and very complementary to tree preservation. That being, think back to that wine glass analogy of the tree root zone being about 30 centimeters deep. And then an HDD or microtunneling activity is usually very deep and quite small in the case of its disturbance. So we highly recommend that. With the other option is open cut or trenching, which is obviously very, very difficult.
I do have a hand raised by Max Dita. However, Max, we receive questions through the message board. So if you don't mind, if you want to write your question down quickly, and then I will actually recite the question to everyone, and then Kevin or Mackenzie will respond accordingly. Okay, we've got a few questions here now. One question, Kevin. What is considered a tree DBH greater than 150 millimeters, and is it consistent across all municipalities?
Yeah, so I'll answer that in reverse. Municipalities have different scale of tree protection that they are interested in regulating. For instance, the city of Toronto, if you're on private property on, let's call it table lands, trees 30 centimeters and greater are of most interest. Trees of all sizes within ravines and natural feature protected areas, rights of way, and parks are important. So the 15 centimeter cutoff is sometimes considered by municipalities in absence of some tree protection policy. 10 centimeters is sometimes considered the minimum. After that, it's considered brush. Hope I've answered that question.
How effective are root deflections for protecting trees and underground utilities?
mean, I can speak to that unless Mackenzie would like to.
Go ahead, Kevin.
Okay, I would say within reason. Keep in mind the ideal that the tree would like to have is that wine glass analogy. So one thing that you'd want to consider is at what growth stage is the tree in before you put these deflection technologies. For instance, are you putting that pipe or trail in that you're keeping it away from, and you've got a mature tree there? I mean, do you have to sever the root to put in the deflection technology? That can be concerning. Otherwise, a new tree planted with the deflection technology may have may skew the root zone, so it doesn't have that balance. So approach with caution, and maybe the tree protection zone could be considered to use as your metric for installing those technologies. Nothing closer than that. Philip?
Yeah. How often are you seeing hydrovac and root pruning prescribed within a tree protection zone?
I mean, I can jump in about that. Hydrovac is becoming very common, especially on our public works projects, because trees often correspond with where utilities are and within road rights of way and grass verges or boulevards, whatever we want to call them. So if we've got natural gas lines or water mains in there, it's always approached with caution or low impact. So we're seeing hydrovac as very common. I'd say the other technology that Mackenzie talked about with air spade, that's a proprietary name, but air excavation is less common, but not uncommon. In terms of root pruning, I would say that's common in some cases. That's another thing we really approach with caution. There are some ideals that we'd like to see in terms of the season. We wouldn't want to have an exposed root zone in the middle of July or August, or even January, February, when we've got dryness of the root zone that would really work against the long-term health of that tree. It is important to do when we're pulling curbs apart during road projects or putting in new pipes, just to make those nice clean cuts that can then be covered, and then that often a new root will or series of roots will be created as a result of that cut. Thanks, Philip.
Thank you, Kevin. What is your opinion of new tree placements in an existing right-of-way and the challenges cities have with new trees nearing existing utilities? Example, City of Toronto has a policy of no new trees above existing sewers/water mains.
Yeah, important questions to have, and some municipalities will have guidelines to landscape plans, and they'll have the thresholds for separation, against public utilities, the street lights, stop signs. There's view sheds to protect. Unfortunately, there's a right place for every tree, but there's wrong places as well. So it's what we understand is there's less and less space available for trees, and there's risk that's taken on either by the wrong tree in the wrong place for the long-term success of the tree. Otherwise, if we've got to get into that utility, whether it's natural gas or pipeline, we're just going to be pulling it out. So it's worth putting in trees, and having respect for the thresholds for setbacks. At the same time, really keeping in mind how deep some of these utilities can be, knowing that most trees are only going to go 30 centimeters or deeper. So some loosening may be required so we can get some trees in public spaces. Thanks, Philip.
Just got a few more questions here. Sidewalk, concrete work can impact trees greatly from root disturbance and or um, pH changes. What is the best practice to mitigate impacts to tree health?
Okay, so if we've got existing sidewalks that we're looking to take away, there's definitely some care that can be taken with that. Often it's a big bucket approach to tearing it out, and perhaps there's some finesse that comes with it. pH was raised. I can't anecdotally say that it's something I've seen affect trees. We do, in the most part, in south and the south part of central Ontario, have pretty neutral soils, and so the concrete doesn't seem to impact them or dissuade trees from growing underneath. In terms of putting in new sidewalks, I mean that's a conflict that Mackenzie and I would definitely be having our eye on, because there's not only the plate itself of the solid portion of the sidewalk, there's the subgrade as well, which sometimes will go to 12 centimeters or a foot below that poured concrete. So that's not too dissimilar from an open cut or trench excavation. So depending on how much encroachment into that tree protection zone, this is where sidewalks can be very problematic to destabilizing that wine glass. Philip?
Okay. If we remove some specific species of tree in the public property, do we need to replace the same kind of tree or replacement of any tree, any type of tree will be acceptable?
I think I can get the gist of that. So, and not all trees are created equal. Obviously, there's a changing dialogue about introduced species. At one point, Norway maples used to be the favorite because it's very urban tolerant, and it's fallen out of favor in some cases, especially on public plantings, to use it, knowing that Norway maple can be a very invasive species. Another darling of street tree planting through the 90s and early 2000s, because I was involved in the problem, was planting Marshall seedless green ash everywhere. And many of our folks on the call will know about the emerald ash borer story, and how there are certain parts of Brampton and Mississauga and Oakville and Burlington that lost their trees in one fell swoop. Another thing could be considered is the change of land use, where a large tree may have been appropriate and may exist in that public realm. If we're putting overhead wires there now, or that may be a constraint with, or view shed if we were putting in new traffic signs, something smaller in stature. Sometimes we call smaller trees shrubs or shrees, and that's that gray zone between shrubs and trees. And there we can look to smaller statured things to replace that lost canopy, while not replacing like for like. Philip?
Thank you very much, Kevin. Do you have or recommend any research on efficacy of drip line as a proxy for tree protection zones? I think many of us use that as a standard. Do you know of any research on ability of trees to withstand root disturbance in this area?
So what I can tell you from some research I've seen and some presentations I've seen, there's at least as much turnover below grade as above grade. So if we think about all the leaves that come and go over the season, there can be that much biomass turnover underground. So roots come and go, they'll grow, die, and new ones will start growing in another place. So we're always going to be impacting tree roots. That one diagram that we had that showed the root zone extending 2 to 3 times the actual drip line is not uncommon for a number of species. So the tree protection zone, I mean, our bylaw folks on this call would agree, should be considered a minimum. And that's based on an overall species insensitive approach to standardizing measurements so that practitioners such as us that do excavations have some basis of setback. But we've all been around the big apple trees that they'll be extending far wider than they are tall. Otherwise, the narrow conifers that have a very narrow canopy, I think that provides a false positive or a false sense of providing sufficient setback. So I think the tree protection zones were generated to level the playing field. Philip?
Okay. So we're just after 1 o'clock now. Kevin, what I'll do is I'll read you 3 more questions and then wrap up. Construction assessing the tree risk of falling when excavation is within the tree protection zone.
Okay, so the assumption with that would be that potentially an arborist wasn't involved in the planning. So the threshold of the impact to the tree was to impact was maybe understated or not considered. So let's go with that route. To get an easy answer is challenging because Mackenzie did talk about the different tolerances of species. We've all seen where curbs and sidewalks have been pulled away or put in next to Norway maples who have a high tolerance, and in some cases you could plant in the middle of a parking lot and would do just fine, thank you very much. And then we do have some more sensitive trees that would be challenged with some of that construction happening within the tree protection zone. So I'm going to make a plug for, again, getting an arborist involved in the process so that the failure to plan is planned to fail. But if you're at a period where you've now ripped through the root zone with a trench and you need some level of comfort with if that tree is going to fall down today, tomorrow, or 10 years, an arborist may be able to assist with that. Mackenzie and I, you'll see that we don't both have a certification that says TRAQ. That's the Tree Risk Assessment Qualification. So that's in addition to the arborist certification that just allows us to identify tree risk based on the factors that Mackenzie talked about what is the tree, what is the potential target, and what's the likelihood of it failing, and the result of the failure.
Okay. A lot of the tree protection recommendations you made are costly to implement. How does a municipality balance the taxpayer costs to protect a mature tree that may be nearing end of life? You know, that's a tougher question, almost a philosophical question as well.
It is, and that's where it's difficult to, and that answer might be different per municipality. Mackenzie alluded to some of the higher density municipalities may consider trees to be an asset, and an asset is all very appreciated, much like street furniture or a bridge or a bus shelter is great if you keep up the maintenance, and that there's an inflection point when it becomes a liability. Whereas in some of the more rural municipalities, trees might be considered a resource, and there's nuance between those, but generally a resource needs to be managed and maybe is considered more valuable as part of a grouping as opposed to an individual that an asset matters. So In terms of a tree towards the end of its life, that would be determined by the arborist. And with that can corrective actions be made to make it worth saving that tree? Otherwise, our arborist reports will identify if a tree is just not worth saving. We will recommend a tree for removal just based on its health and condition. It may not be impacted by construction, but it may provide a long-term issue for the occupancy, whether it's trails or access or roads. And then in terms of the cost, in the case, if I showed the example of the snow fence and on 2x4s, so that's a really small expense if that's all that's needed. I mean, in some cases, that's a reusable thing. Modular fencing is starting to be used by a lot of our clients. Again, make sure it's staked in and does not move over the course of the project. So the challenge, I think, does come up when wood panel hoarding is required and page wire, because it's often needs to be disposed of after the project. So there could be some discussions happen with the powers that provide the permit to reduce the disposable tree protection equipment without compromising the protection it's providing. Philip.
Okay. So we have one last question that I think it's a good one to end on. But before I read it, I just want to share with you as well. I've got a number of comments where folks are thanking both you and Mackenzie for a great presentation, very informative presentation. So I wanted to share that with you. I have a number of comments like this here as well. For the final question, if an arborist could be engaged only during one phase of the project, which would it be? Project planning, so that includes tree impacts, tree mitigations, proposed planting locations, planning side, or during construction or post-construction. If they could only choose one phase, what phase would that be?
So there's an imponderable, but we'll ponder it. So definitely the front end. Providing, I mean, a lot of these road development projects we work on, the tree preservation plan is really brought to life at the 60%. Subsequent stages include the 90 and 100%. Sometimes there's 100% prime as little changes happen. But really that 60% is critical because that's still an opportunity to change the design while understanding what your tree resources are out there and making those changes. So as long as that information is respected in future iterations of designs, the beginning, if I had to choose. Thanks, Philip.
Okay. Very good. Very good. Well, I echo the sentiments of my fellow OPWA members. I'd like to thank you very much for a very informative presentation. I'd like to thank you, Mackenzie, as well, for a very informative presentation. And with that, I would like to call this webinar to a close. Thank you all. Bye-bye.
Thank you.
Thank you.